Today we're going to explore one of the most iconic structures in the depths of space by examining the NASA, ESA, CSA, James Webb Space Telescope's sharpest infrared images, the Horsehead Nebula. The new images, with avant-garde spatial resolution, capture an iconic part of the Horsehead Nebula in a completely new light. These observations depict a section of the sky in the Orion constellation, situated on the western side of the Orion B molecular cloud. Rising from turbulent waves of dust and gas is the Horsehead Nebula, also known as Barnard 33, located approximately 1,300 light-years away. The nebula, formed from a collapsing interstellar cloud of material, shines because it's illuminated by a nearby hot star. While the gas clouds surrounding the Horsehead have already dissipated, the protruding pillar consists of thick clumps of material that are more resistant to erosion. Astronomers estimate that the Horsehead has about 5 million years left before it disintegrates. Webb's new perspective focuses on the illuminated edge of the nebula's distinct dust and gas structure. The Horsehead Nebula is a well-known photodissociation region, PDR. In such a region, ultraviolet light from young, massive stars creates a predominantly neutral, warm area of gas and dust between the fully ionized gas surrounding the massive stars and the clouds in which they are born. This ultraviolet radiation strongly influences the gas chemistry of these regions and serves as the primary source of heat. These regions occur where interstellar gas is dense enough to remain neutral, but not dense enough to prevent the penetration of far ultraviolet light from massive stars. The light emitted from such PDRs provides a unique tool to study the physical and chemical processes that drive the evolution of interstellar matter in our galaxy and throughout the universe, from the early era of vigorous star formation to the present day. Due to its proximity and its nearly edge-on geometry, the Horsehead Nebula is an ideal target for astronomers to study the physical structures of PDRs and the evolution of the chemical characteristics of the gas and dust within their respective environments, as well as the transition regions between them. It is considered one of the best objects in the sky to study how radiation interacts with interstellar matter. Thanks to Webb's MIRI and NIRCam instruments, an international team of astronomers has revealed for the first time the small-scale structures of the illuminated edge of the Horsehead. They have also detected a network of striated features extending perpendicular to the PDR front and containing dust particles and ionized gas entrained in the photoevaporative flow of the nebula. The observations have also allowed astronomers to investigate the effects of dust attenuation and emission and to better understand the multi-dimensional shape of the nebula. In the next step, astronomers plan to examine the spectroscopic data obtained from the nebula to reveal the evolution of the physical and chemical properties of the material observed across the nebula. This data analysis will help us gain a deeper understanding of the physical and chemical properties of the material observed across the nebula.